Welcome, GAPsters. Thank you so very much for joining us to this session. Today, we have the pleasure of hearing from Carlos Fernandez, who is going to present the talk, A Gentle Introduction to Data Science. Okay, Carlos, it's a former GAPster. Actually, he was telling us some stories about his journey in GAP, but I'm going to tell you a little bit more about him. He's a professor. A professor of systems at the HKUST Business School in Hong Kong. He is a data scientist who specializes on the use of machine learning for large scales automated decisions. Okay, he has worked on research projects with companies in different industries, including Spotify, VIA, and BAC Credomatic. The results of his research have been presented at multiple conferences worldwide and accepted for publication in top academic journals, such as Information Systems Research, MIS Quarterly, and the Journal of Machine Learning Research. Carlos received his PhD in Information Systems from the NYU Stern School of Business. His two favorite hobbies are singing and playing Dungeons and Dragons with his friends. Thank you, Carlos, for your visit to GAP. I know that we are all eager to hear from your insights, so the stage is yours. Go ahead.
Cool. No, thanks a lot for having me here. I'm seeing familiar faces. Hi, Eduardo. Hi, Andres. Really good to see you. As you were saying, William, I worked at Gap before, and it's very nice to see you guys after all these years. Rodrigo was saying about this old picture of me. So this picture was 12 years ago. It was October 2012 for a Halloween party at Gap when the offices were still like in this house near Plaza del Sol. And so, I remember very fondly working there for sure. And so it's very, very nice for me to see you guys again for sure. So to give you a little bit of context of my journey since I left Gap, I basically am on the intersection between business and tech nowadays. So my PhD was very technical. It was information systems at NYU, but I did it at a business school. And so a lot of the emphasis that I put in my research and my work is basically not only on the development of these AI systems, but actually on delivering business value out of these things. And so most of my job is indeed on the development of machine learning algorithms, but I tend to work very closely with companies to try to bring about this value. So for example, with the Spotify, it's not only about building a recommender system, but about giving recommendations that are going to switch people from free to premium, right? So how do we measure success? It's not better predictive power, it's actually switching people to pay, right? So with VIA, it's a ride-sharing app. So basically it was, how do we convince people to refer our services? For BAC Credomatic, how do we convince people to take on certain financial products? For Distillery is, how do I target my marketing budget in a way that I maximize the purchases from different people, right? And so this is kind of the work that I do. I'm a professor of data science at Hong Kong University. This picture that you can see over here on the right is the picture of our campus. If I could open a window there and there was not like this bright light, you would be able to see the sea behind me. But with the light, probably not going to be able to see it. So this is pretty much my journey. I went from being a software developer at Gap to becoming a data scientist. And so far, I think has been quite well, particularly because of how hot the topic has become. So about 10 years ago, there was this Harvard Business Review article that made a lot of waves in industry. And it was basically this article promoting this idea that data scientist was going to become the sexiest job of the 21st century. Now, at the time, there was a lot of hype, and some people were saying, yeah, it's not clear that companies are quite there because of data issues, because of how difficult it is to manage things like privacy and governance and things like that. But 5 years after that article, you could see this humongous increase in companies hiring, specifically in the US, like companies hiring data scientists. This data is a little bit outdated, but it's the one that I could find right now without doing like in-depth analysis. It still is data about what happened from when the article was published in 2012 to what happened when it was published in 2018. And essentially, you can see that the demand for data scientists is off the charts. This is information collected by LinkedIn for the workforce report of the US government. And you can see that machine learning engineer, 10 times growth in 5 years. Data scientist, 6.5 growth. Big data developer, 5.5. Director of data science, 5 times. So you can see that companies are trying to hire data scientist related positions like crazy. And you may be wondering, where's the hype, right? And so I'm going to show you now some of the applications that are essentially informed by data-driven systems that would be built by data scientists. The recommender systems that we use at places like Amazon or Netflix or any of these platforms are essentially data-driven. They're based on things that people pick in the platform. And so based on what you have picked before, different products, different movies, different songs would be recommended to you. Trillion-dollar businesses like Google target their ads based on data about your daily behavior, things that you browse, apps that you use. The inventory management at Amazon is also based on data. So it's not somebody that is trying to estimate the demand for each of these products independently, but instead it is completely automated in a way that data-driven systems are making these decisions about inventory. Prices at Uber are completely automated, right? It's not that when you decide to take on a cab, somebody's calculating the price. And so the optimal price to charge for a route is also based on AI data-driven systems. Stock trading nowadays, I would argue that at least 50% of the transactions that are made, no, sorry, not 50% of the transactions, 50% of the volume of money traded in the stock markets is completely algorithmic driven based on AI systems. This picture over here is from a friend and colleague of mine that works for a real estate company that makes decisions based on AI systems. And essentially, it's a picture of Manhattan in New York. You can see that there's like some things that are kind of redder than others. Like so there are some properties that are highlighted in red. And essentially what this means is that this is a property that is very likely to be sold in the next year. And so what this company would do is that they deploy their agents to these properties that are very likely to sell within a year so that they can offer their services to buy or sell houses and then get the commission, right? And so again, this is AI-driven systems informing decisions of which customers to pursue. It's also been making waves in healthcare. So as a picture, radiologists are using these AI systems to identify lung diseases in this case, right? And so based on the picture, that's data, right? And based on a bunch of different pictures from different diseases that have been encountered in the past, then the system would be able to estimate how likely is this person to be suffering from a specific lung disease based on that picture, right? And so it's also making a difference in healthcare. This picture over here, believe it or not, was made by a machine. So nowadays, people are talking a lot about generative AI. And so the idea here is that you can use historical data to generate new data, right? By recombining that data in a smart way. And so essentially, we have a bunch of different pictures. Maybe we can combine these pictures in an interesting way to produce a new picture, right? And so maybe you have heard of something like Midjourney, right? That would fit into this. And so this picture over here actually won the first prize in an art competition. So it was a state level competition. I believe it was in Colorado. And this person participated with a picture that was fully created by an AI system and won first place. Okay. Now, self-driving cars are also based on these AI systems. And so the ability to take an image and predict what objects are in front of the car, it's also based on predictive models that are fed data, in this case, pictures of things that are around the car. And most likely, you've also heard about OpenAI's ChatGPT system. It is also based on a data-driven predictive model. And so all of these different applications that I'm showing you are essentially the reason why there is so much hype around hiring data scientists, because all of these applications are essentially developed based on the premise of data-driven systems. Now, I want to emphasize that these applications for data-driven systems, they are not industry specific, right? It's not only about tech companies, even though this may suggest that it is. It is not only about tech companies. You can use these systems to inform inventory decisions, customer service decisions, supply chain, marketing, sales, all of these things. And so the potential of applying data science tools to all sort of businesses and daily life decisions is huge. And I think that this is only going to grow. Like it's not going to go away. And so when people were talking about these data scientists being the sexiest job of the 21st century, I do not think it's going to be something that is going to happen for the next 10 or 20 years. I think it's going to happen over multiple decades, in the same way that when computers were introduced, it radically changed the way we live our lives. Now, with this said, I want to emphasize a very important lesson from another Harvard Business Review article, that basically it's about understanding that data initiatives can't just be for data scientists. So there is this concept or notion that, if you're learning about data science or AI or machine learning, then that's because you want to be a machine learning engineer or a data scientist. That's not the case at all, because it turns out that if you want initiatives to be successful, the data teams must work closely with regular people every day, right? So the focus should be on equipping people with the tools they need to formulate and solve their own problems. So that means that somebody from marketing is going to need to understand basic concepts about data science, right? Like somebody from finance, somebody from operations. And if you're working on just developing applications, right, as a software developer, you would also need to understand data science, because chances are that whatever system you're going to develop is going to relate to some extent to data science, either because of data collection or because a critical component of the system is going to be based on a data-driven component, right? And so this talk is essentially about me introducing what data science is, how the process of creating these systems work. I'm going to do that for the next maybe 20 minutes. I'm going to basically give you this gentle introduction to what data science is. But after that, I would like to have a conversation, right? So at any point, feel free to interrupt me. And at the very end, I'm going to leave a big chunk of space, maybe 20 minutes or so that you can ask me anything, right? It doesn't have to be about the presentation. You can ask me about my opinion about any other data science related issue. And I would be happy to give you at least an informed opinion of your question. So let's start by discussing what is data science, okay? To discuss what is data science, I want to give a motivating problem, okay? Imagine that we have this human recruiter, and this person has to go over hundreds, if not thousands, of job applications in order to decide who should we call for an interview. Now, it's a repetitive task, and it requires you to go through a humongous amount of CVs. And so one possibility would be to, instead of delegating this task to a human, have an AI system that will go through all these applications, and based on the information of the applications, would be able to tell the human, oh, I believe that you should interview these people, or no, these people you should not interview. Now, something I want to emphasize here is that when I say AI system, I don't mean like super complicated system in the box. I mean just a system that is doing a task that we normally would delegate to a human. So it doesn't have to be a super complicated thing inside the box. It's just a box that can do a task that normally we would attribute to a human. Now, the data science process is a way of building the system in a data-driven way. So artificial intelligence has a very long history. Like it's been around for 70 years. Now, the hype now is that we have managed to find a way of automatically building this system in a sense from historical data. And so now with humongous amount of data, humongous amount of computing power, we have figured a way of automatically extracting, let's say, this artificial intelligence from the data. Before it was not like that. Before people would codify that knowledge inside the machine, right? And so the way people were doing AI in the 80s was by codifying the system, coding the system. That is not how it's done now. Now, there is a very important component which is called machine learning, which essentially is our programs that are designed to extract the knowledge from the data so that we can take this knowledge and put it inside an AI system, okay? So essentially, when I'm saying data science, I'm talking about this field that is doing some systematic extraction of knowledge from the data so that this knowledge can be incorporated in an AI system and then used to take some action. And that is essentially what data science is about. Now, this is a very overloaded explanation. And so what I'm going to be doing next is basically decompose this definition piece by piece. And I'm going to start by talking about what do I mean by knowledge and what do I mean by using this knowledge? What exactly is the goal of data science? Like we're extracting knowledge, but what does that mean, right? So when we're making decisions as humans, essentially we have knowledge based on our past experiences. We have a piece of evidence, and when based on that piece of evidence, we're going to make some reasonable guess or inference about what would happen next, and based on that, take an action. And so in the case of the example that I provided, maybe we have a human recruiter that has seen a lot of applications in the past and knows which of those candidates that were hired actually led to a good hiring, like were good hires or not, right? So a check means this person was a good hire, and X means this person was not a good hire, right? And so this person has seen a lot of these applications in the past, and now a person is applying for the job, which is this doctor over here, right? And so this person may compare how similar this person is to people that were hired in the past, or how similar this person is to people that were not hired in the past, right? And so based on that, he would be able to make a reasonable guess. Oh, I think this person would be a good hire. And if I believe that this person could be a good hire, then I would take the action of calling this person for an interview, which is the right side, okay? So essentially, what we want to do with data science is extracting a predictive model or a system that can make this inference, right? So this system is built based on lots of applications that we have seen in the past and based on how successful or not successful the hired people were, so that when a new application comes in, based on all that historical data, the system can take a reasonable guess at whether this person would be a good hire or not. And based on that, we take the decision of whether to hire the person or not. And that's pretty much what data science is all about, extracting such sort of knowledge. Now, something I want to emphasize here is that we should clearly distinguish between making a prediction and making a decision. So in this case, the system could be doing both, right? But when we're doing the machine learning, when we're extracting a pattern from the data, normally what we're trying to do is build a model that can make a prediction. And so this model that can make a prediction could be, I want to predict if this is a good hire or not, right? And based on my prediction of whether this is a good hire or not, I would decide to call for an interview or not. And so one thing is to call for an interview or not, and another one is to decide, one thing is to decide whether to call for an interview or not, and another one is to predict whether this would be a good hire or not. These are different components, and I'm going to go deeper into those in a bit. But the reason why I'm saying that is because many times the AI system is not making decisions automatically, right? Like in the example that I gave before, it seems that the system is predicting if they would be a good hire and then making a decision automatically. But in practice, very often it doesn't go that way. You have a model that makes a prediction, but then the final decision is made by a human. And so to give you an example, in the US, judges are judges' decisions of whether to give bail to somebody or not are informed by predictive models. And what the predictive model or AI system is doing is predicting the likelihood that the person will commit a crime if they are released on bail. And so basically, the system tells to the judge, I believe that if this person is released in bail, there is a 20% likelihood that they will commit a crime. Gives that to the judge. And then the decision of whether to give bail or not is up to the judge. It's not up to the system. And so again, the system is making a prediction, but the decision is made by a human. So why is this distinction so important? Because many times when people are developing these systems, they're just thinking about, oh, I just want to improve predictive power. But it doesn't end that way, because you need to understand how the predictions will be used to inform decision making. And so a big part of being successful in developing data science systems is a better understanding of how the system will be used. And so I said at the very beginning, the data initiatives should not be only for data scientists. It should be, for example, for judges, right? If the judge doesn't understand how the AI system was built, if the judge doesn't understand the limitations of the system, it's going to be hard to use the prediction of the system in a way that would be useful for the decision making, right? And so the judge should understand a little bit of how the systems work. Another example is in healthcare. You could have a system that is predicting how likely is this person to have a lung disease. That is just a prediction. It's not a decision. The person that is making a decision is the physician. And so the physician could decide, oh, based on that prediction, I think we should do a biopsy or not, right? I would say like maybe 10% prediction of a disease is enough to do a biopsy, right? Maybe it's not. But in the end, the decision is up to a human. The prediction is a machine. Another example, this comes from my friend, colleague and friend in real estate. This system essentially tells the real estate, the real estate agents, these are properties that are very likely to be sold within the year. So check them out. And so the system just predicts what is likely to be sold. It's not making a decision. The final decision is the real estate agent going to the house of the person that is going to likely sell, right? And offering the service. And so in the end, if we don't understand the needs of the real estate agent, of the judge, of the physician, chances are the project is going to fail. And so what I want to emphasize here is that the use of the knowledge is everything. And so when I said that data science is also about the use of the knowledge, it is very important to understand how the patterns that I'm extracting from the data, which could be a predictive model, for example, are going to be used to inform a real-world application. Now, with this said, I want to talk a little bit more about the data part in the concept of data science. And so it's this idea that there is something in the historical data that I could potentially use to inform my future decisions. Now, people often think that if I have historical data, then I obviously would be able to predict, to find a pattern that will be helpful to predict the future. Now, sometimes you can find a pattern that is actually not useful at all, but still a pattern, right? And so I have this funny picture from a book called The Black Swan. It's pretty cool. It's about cycles in the stock market. And essentially what this is showing is the well-being of a turkey in his life, okay? 1,001 days in the life of a Thanksgiving turkey. And so you can see that there is a pattern for sure. As days pass by, the turkey is well fed and loved by the family. You know, like they even put a name to the turkey. Everybody's having a great time with the turkey. But then comes Thanksgiving and the turkey, you know, is not going to be doing so well anymore. And so what this picture is showing is that historical data is not necessarily predictive of the future, right? At least not in the long term. So you may believe that based on the pattern that you observe up to day 800, like the 800th day, based on that pattern, the turkey is still going to be doing well. But without having some clear understanding of the context, you're going to make the mistake that this trend is going to continue for the rest of the future, right? And so a big portion of data science is actually not only on understanding how the system will be used, but also on understanding the extent to which the data that I'm using to build the system could inform a situation where I need to take an action. And so going back to the example that I was promoting with recruiting, imagine that in our company, in the past, we have only hired engineers. That's it. We only hire engineers. If they don't have an engineer background, we don't hire them, okay? And then somebody comes in and they're an accountant. Now, when I'm building my system to determine whether somebody would be a good hire or a bad hire, I have some selection bias in my data because the only people that I have ever hired are engineers. But then when I'm trying to analyze the profile of somebody that I have never hired in my life, like profile completely different of everything that I have done in the past, then we should question ourselves, is this system, is this pattern that I'm extracting from the data actually going to allow me to make a good decision about this person? And the premise here is that the data must generalize to the individual about which we want to make an inference. If garbage comes into the data science process, garbage is going to come out. Now, it is our job as data scientists to understand the extent to which the data is garbage or not. And that is domain specific. So I said again, these initiatives are not only for data scientists, because in my case, for example, I'm a data scientist and I would not be able to know for sure if this information over here is going to generalize over here. I would ask a human resources person, right? For me to understand if this data can generalize, I need the support from the human resources people. And so involving them in the process of developing the system is actually very, very important. The data scientist on his own would not be able to solve the problem. It requires domain knowledge, okay? So this brings me to the science part of data science, right? So I discussed before the purpose, which is the row below. I discussed the ingredients, which is the data. And now I'm going to talk about the science, which is actually extracting a useful pattern from the data, assuming we have the right data and assuming we understand clearly how the result of the data science process is going to be used. Now, for this, there is this very useful framework, which is called the data science process, which is normally used to develop data-driven solutions. Now, a lot of people focus on the machine learning part, which is all these crazy algorithms that you have to learn a complex pattern from data. And that is pretty sweet. But we also have to consider this is only one stage in the process, right? So for us to do an appropriate development of a data science solution, we must understand the business in terms of what the goals are. We must understand whether we have the appropriate data or not, which relates to my point about garbage in and garbage out. These are domain-driven things. We must also do a humongous amount of work on extracting, integrating, cleaning, and transforming the data. In my experience, between 60 and 80% of all the cost is really on having like clean data and structuring it. The amount of time that we spend in machine learning is actually way less than we spend in data preparation. This is where most of the work is. Then critical thing, build a system. Is this system going to lead us to success, right? Can we make decisions with that? So maybe, yeah, I have a model that can predict if somebody will have a disease or not, like a lung disease or not, like to some extent, like predict the probability. Are the physicians actually going to be using that? How are the physicians going to be using that, right? So for us to understand the success of the solution is not only about predictive power, but about understanding whether it can drive business outcomes. And for that, right, we need to understand how the system will actually be used, not how good the predictive power is, but how will the system be used. Now, I want to jump into the machine learning part so that you get at least some idea of the technical concepts behind it. And so here, I want to go back to this picture and basically think about this box not as an AI system, even though people call it like an AI system nowadays, but as a data-driven decision-making system. Because essentially what you have is you have some data about something called an instance, which is the unit of analysis for which you need to make a decision. So it could be, for example, data about a job applicant, right? And the system, based on data of this instance, is going to take some action. which could be, for example, call or not call for an interview, or just make a recommendation for a human to take that action, right? Now, if we look inside the AI's head, what is really happening is this. So remember that I said it was very different to distinguish between the prediction of the model and the decision that is made with that prediction. And so essentially, when AI systems are making these automated decisions, essentially what is going on is that we have this model, like this crystal ball, that is a predictive model that, based on this information from the data instance, is going to predict some quantity that I don't know, but I would love to know to make a better decision or a better recommendation, okay? And then I have some decision logic. This is coded, essentially. It's a program that would be able to incorporate that prediction into some decision-making process to take an action. And so to give you an example, maybe we are interested in calling for an interview anybody that has more than 20% chance of being a good candidate. So, even if your chance of being a good candidate for a job is only 30% or 40%, maybe it is still a good candidate for calling for an interview, because the cost of an interview is normally way lower than the cost of missing out on a great candidate. So you would be willing to call somebody for an interview even if he's not a great candidate. So it shouldn't be, oh, it must be about 50%. No, maybe it's fine if this person only has a 20% chance of being a good candidate, right? And so the decision logic is essentially that. I make a prediction of how good of a hire this person would be, and based on that estimation, which could be 30%, 20%, 5%, I make a decision of whether to call somebody for an interview or not. And again, here, the perspective of the human resources person is going to be very, very important about what is the cost of calling somebody for an interview versus missing out on a great candidate, right? Now, this is what people would call the AI system in use, or the inference stage, because we're making an inference about a piece of data. How it looks in practice, the data instance looks like a row in a spreadsheet, and we have a bunch of different attributes or feature columns that we're going to be using to make a decision. And so in this picture that I'm showing you here on the left, the data instance, which is the job candidate, would look something like these rows here. So X1 means feature one or characteristic one of the applicant. And so this 7 could be the number of years of experience. So this person has 7 years of experience, and I want to use this 7 to predict this Q, which is whether this person would be a good hire or not. Like, if I were to hire, would I be satisfied with their performance? Yes or no, right? So this is the Q over here that I don't know, because I haven't hired this person, so I don't know if they would be a good hire or not. Now, X2 could be, maybe does this person has a master's degree, right? And so T stands for true. This person has a master's degree. And X3 could be their favorite color, Sometimes you may be including variables that you don't know a priori whether they're going to be informative or not, but you included them and let the system tell you whether that would be informative or not. I would not expect the favorite color to be important in this case. Ideally, you should be including variables that are important. But what I'm saying is that sometimes the system may be able to get some data and decide, oh, this piece of data is actually not relevant to make this decision. I'm going to take it to the other side. Like, I'm not going to consider that when making the decision, right? Now, machine learning is the process through which we would build this magic crystal ball, okay? So actually, machine learning algorithms and AI systems are actually different. They're not the same, but people confuse them all the time. The machine learning algorithm is the process through which you get a predictive model, okay? And the AI system is the use of the predictive model to take an action, right? And so the predictive model is actually a component of the AI system. And so when I said at the very beginning that AI has gone through a bunch of transformations, is because in the 80s, this predictive model over here would be completely coded, right? And now we found a way of not coding this from scratch and instead extracting this model from the data through the use of a machine learning algorithm. And so what we code now, what we are coding now is we have a machine learning algorithm that has been coded, and this algorithm can generate a model that essentially works as a program, and this program can be combined with the AI system to make decisions that normally would be attributed to humans. Now, how does machine learning work? Well, essentially, we have this quantity that we want to predict, which is Q, right? Is it a good hire or not good hire? And we have a bunch of instances that have exactly the same attributes or the same features as I would have when I am making an inference, right? And so for each of these persons that I hired in the past, I must know how many years of experience they had, whether they had a master's degree or not, their favorite color. And these are people that I already hired, and I already know whether they perform well or not after they were hired, okay? And so essentially, based on this historical data, my hope is that I can predict in the future when I see similar attributes to somebody that was in my historical data, I can predict whether they were going to be a good hire or not. Now, here, what the machine learning algorithm is going to do is tease out correlations between the X's and the Q. Essentially, when the years of experience goes up, is the chance of Q being yes higher? The machine learning algorithm has a systematic procedure to assess whether these variables move together or not. Essentially, you are automating statistics inside the machine learning algorithm. And so this algorithm is a systematic way of extracting from this data those patterns or attributes that would be informative of somebody being a good hire or not, okay? Now, I want to make a pause here, see if anybody has any questions about this picture. I'm going to do a test question in a bit, ask you guys to tell me whether something is machine learning or not. But before I do that, I want to make a pause and see if there is any questions about the concepts that I have described here. Okay, so let me do the test. So basically, the question is, are self-driving cars doing machine learning while they drive? And so what I want you to put in the chat is just yes or no. Do you think yes, they're doing machine learning, or no, they're not? Anybody thinks yes? Okay, so very good question, but Darren, I'm gonna go back to that. So you guys are the first group that actually nailed the question in its entirety. So the AI data, the Data AI Fest has been working quite well. Yeah, you're right. It's not. So what's going on here? And I'm going to go to Darren's question in a bit. So what's going on here? So the data that I'm using in this case is the image, right? So I can take this image, and believe it or not, I can take, well, you would know, guys, because most of you have a technical background in computer science. So you know that each of these pixels actually represents 3 colors in numbers, right? So I can represent any pixel in this image as a combination of red, green, and blue. And each of these red, green, and blue is a number between 0 and 255. So basically say like how red something is, how green something is, how blue something is. And so this picture is just data, right? And so in this case, the data instance could be simply an image, right? And what I would like to know is to predict what objects are in front of the car. So each of these boxes over here are essentially predictions by a predictive model of what is in front of the car, right? And so here, the predicted quantity could be not one quantity, could be multiple quantities, and it could be objects that are in front of the car. And based on those predictions, the car would take an action such as, based on some decision logic, such as steer left, steer right, accelerate, brake, right? And that is the action that is being taken by the car. And so the self-driving car is the AI system in use, right? But the way the object detection system was built is not created as you drive along. You know, this was done in a carefully tailored lab to understand how to predict objects and develop a machine learning a machine learning model, right? Like the model itself, to develop the model so that it can predict things in a controlled environment, right? And so the machine learning is not happening while the car drives in the wild. The machine learning happened in the lab of Tesla or whatever, right? Now, Darren asked a very important question, which is, feed the AI inference back into the machine learning flow? Yes, right? So what could be happening is something like this. As the car is driving around, right? The car is driving around, it is collecting data. It is collecting images, right? And as the car is driving around, you will also figure out if there was any issue, right? Like maybe the car got closer to what you would have liked to certain car or certain people, or it accelerated more than it should, right? Like there could be errors that happen as the car is driving. So as the car is driving, you collect information about images, but you also collect information about how good the action taken by the car was or was not. And so once I collect that data, then that would be part of my historical data now, and something that I could use as part of the machine learning to build a better car in the future, right? And so as Darren pointed out, as the car drives, it collects data, and then that data you could eventually use to feed back into the machine learning flow. So for sure. Now, the dirty secret of data scientists is really that most of this stuff is really about statistics, right? Like it's really about trying to tease out a good way of finding a correlation between the features or the attributes and the target variable. So having a good understanding of statistics is the foundation for everything related to data scientists. Now, data science. Now, the thing is that people are crazy about machine learning because many of these algorithms are specifically designed to deal with humongous amount of data and to learn incredibly complex patterns from the data. These are essentially computational methods for statistics, right? And so these computational methods for statistics is essentially what we would be calling machine learning, right? And finally, because we're using the results of machine learning to take actions that normally would be attributed to humans, then we use the word artificial intelligence. But in reality, is all grounded in statistics, because it is all grounded in how do I take historical data and make an inference about other data, which is basically what statistics is about. So this is pretty much what I had for my talk. I think that based on this, this time I really emphasize the business part much more than usual, because I feel my audience right now is mostly going to be computer science and maybe some statistics. So I was thinking that maybe you guys have been doing a lot of this computer science, machine learning, and statistics. And so I really wanted to give you a different perspective of the big impact that having a business perspective has to the overall process. It's really not just about the techniques, but understanding the context where the system is going to be used. Now, if you want to learn more about this, I highly recommend this book called Data Science for Business. I think it's a great piece to get an introduction to the topic. And now I think we have roughly like 15-20 minutes for questions, so I'm going to stop now. Thank you very much for your time.
Thank you so much, Carlos. GAPsters, if you have a question, you can raise your hand. You can send it to the chat too, okay? Also, if you have a comment, Andres, go ahead.
First of all, Carlos, good to see you, and thanks for the talk. I wanted to get your input, or if you can foresee how the recruitment process is going to change in the next 5 years. What do you think is going to happen?
So I think it is hard to tell because there are two opposing forces right now. So on the one hand, there is a lot to gain because of the sheer volume of applications that we have. Like you have people that are applying to 50, 100 jobs, right? And things like LinkedIn can capture huge amount of data that was not possible before. And so when I'm thinking about data science applications, normally I'm thinking, is there like a lot of data? One. And two, is this like a decision that is going to be repeated multiple times, right? If you're doing this one, then that seems like as a rule of thumb, it's a good application for data science if you have a lot of data and it's going to be repeated multiple times. And so that makes the idea of using systems to filter out CVs very promising. And there's a lot of push into that. People are calling it people analytics, right? And so I think that trend is definitely going to move forward. The one thing is that companies are very scared because of ethical issues, right? And so people are very concerned about data privacy. And the other thing that people are very concerned is about like a lawsuit, right? Because understanding the extent to which you are discriminating or not against a group is not only a thing about ethics, but it's also a thing about legislation. So even if you're trying to do your best, even if you feel that you're doing the right choice for the people that are being hired, for the company, and you feel clean about your consciousness, I mean, like it's really about the legislation, and the legislation is way behind. And so if the legislation is not moving, this is not going to be deployed by any big company, right? And so, well, it has been deployed, and then there was like so much backlash, then people are scaling down, right? And so I think the outcome is going to really depend on these two things, right? Are we having a humongous amount of applications and we have a humongous amount of data to analyze those applications? Then very strong trend towards adopting the technology. Is the legislation mature enough for us to be willing to try this out? If it's not, that's likely, right? Or if it's like basically going in the opposite direction, where the legislation is such that they would punish you so harshly that it's definitely not worth it. And so I think those are the two major trends to look at. Difficult to tell which way it's going to go.
Thanks. Just a follow-up question there. Like you're saying, like, for example, let's say that we're going to be using a lot of AI systems for predicting if you see a good candidate or will be a good employee in the if it is hired, right? But a decision will be taken by a human. But there are also people using a lot of AI systems to build CVs, to build the resumes. So it will be AI in both sides of that, right?
Yes, I mean, I think that is also a problem. This is different from what you're saying, but related. So I'm in the admissions committee of people here at the university. There's a lot of fake stuff going on. So, like people make up things all the time about positions and about experience and about everything. And, sometimes we catch them, but I suspect there are many people that we are admitting that we didn't catch. I suspect. And so I think for companies, will happen things like that too. If people are using like AI systems in a way to, I craft my CV in a certain way, but then maybe they are hiding something, like the fact that they really cannot communicate, right? Like in the CV, it looks like this person communicates like greatly, right? It's awesome. But honestly, like once you meet the person, they cannot do it on the spot, right? And so like these kind of things for sure are going to be issues. But to tell you the truth, I don't know how to deal with it, because I have been trying my best to see if we can tease out better if somebody's lying in their CV, and it's been very, very, very hard. Like the cost of doing it effectively is very high. And so this is a problem that all universities are facing, I'm sure of it, and we still haven't figured a way of dealing with it. And so I would imagine it's also will be a problem for recruiting, but I think it's an open problem. I don't think there's a solution.
Great. Thank you, Andres, for your question. Next, we have Darren. Go ahead.
So in a lot of these systems, we talk about they're classifying basically, even if it's a yes or no, a 20% likely or not. Is there a way to check the no's under 20%? So a lot of these classifiers are going to be putting things in buckets, and one of those buckets is going to be the trash can, basically. How do we make sure the things in the trash are actually trash?
So I'm going to give you, this is my opinion. My opinion is that classification problems do not exist. It's a problem that was made by data scientists, but they do not exist. The only thing that exists are decision-making problems. And so when people are looking at the classification, they are just wasting their time because nobody cares. So let's go back to this example over here. Well, I think here, the goal is not to classify people as good hires or bad hires. Nobody cares about classifying people as good hires or not hires. Why? Because that is not actionable. It is not actionable at all. People care about using the system to take an action. And so what really matters from the machine learning model, right, like this predicted quantity of interest, is never going to be a classification, or I have never seen a case where I never seen a case where the predicted quantity that matters is the classification. Usually what matters is the score, right? And so this score could be a probability. So you have a high probability of being a good hire or low probability of being a good hire, or it's just a score, right? Like a higher number means more likely to be a good hire. Lower number means less likely to be a good hire. But the classification itself is completely irrelevant. The only thing that matters is whether the outcome, whether the action that is taken is good or not. And so to some extent, we are not really trying to classify in good hire or bad hire. We're trying to classify into person that should be called for an interview and person that shouldn't be called for an interview, right? And once we understand that the classification is really an action rather than the original label, right? Because this label over here, this Q over here, is whether the person is a good hire or not. And people believe that we're trying to classify people into good hire or not, but that is never the case in any practical problem that I have ever seen in my life, right? Like it's always about the action. And so when doing this confusion matrix, we should really be thinking about what actually happened in the data. So what actually happened in the data is good hire versus not good hire, and the action that I would have taken in each of these cases, which is hire for an interview or not hire for an interview, and then understand the cost associated with each of them. And so, for example, we have a cost of calling for an interview somebody that is not a good hire. We wasted the interviewer's time. That is a cost, right? On the other hand, we have a cost of not calling a good hire because there's a potential benefit to the company. That is another cost. It's an opportunity cost, right? And so the way of determining whether we should be using 20% or 10% or 30% or 40% is really about finding the trade-off between these two different types of error, right? The error where I have an opportunity cost, or the error where I have wasted effort, right? And so that is what we really should be looking at when doing this classification, right? But it is not classification of good hires. It is classification of actions by predicting whether somebody's a good hire or not. That is my personal view. I understand that what I'm saying may come across as, what are you talking about for all other data scientists? But that is my personal view on the topic. I don't know if it kind of makes it clear or just more confusing.
It does a bit. I just worry that if you've got it drawn at 20%, there might be some sort of a hole in the classification of people below 20%. So you're missing some quality hires, or there's a misalignment in that 19% and below. Or are you saying that if the result of your actions aren't to your liking, you adjust the percentage until you see a better result?
So it depends on the cost of interviewing somebody that should not be a good hire versus the cost of missing on somebody out. So the 20%, the threshold, to give you an example, would be appropriate if, let me calculate. So it would be appropriate if the cost of missing on a good candidate is 4 times larger than the cost of wasting your time. If that is the case, then it should be 20%. If the cost of missing on a good candidate is 9 times larger, then the threshold should be 10%. And so as the opportunity cost becomes larger and larger and larger, then the threshold that you pick should be lower and lower and lower. So when you're saying that the 20% is not good because you're missing out on these 20% that could be good candidates, what is implicit in your comment is that the opportunity cost of missing out on good candidates is way higher than the opportunity cost of wasting your time on somebody that is not good, and therefore the threshold could be lowered further down. And I completely agree with you. Maybe 20% is not good. Maybe we should go with 10 or 5. But to understand the trade-off between one or the other, I would really need to sit down with a human resources person. Like I cannot come up with a good threshold. On my own, I cannot. I would sit down with a human resources person, understand the trade-off of wasting time, understand the trade-off of opportunity cost, and based on that, try to come up with a reasonable threshold. But if you leave out the data scientists to do it on their own, like me, I'm going to fail for sure, guaranteed. I'm not going to come up with a good threshold that will be useful for the human resources, and that is where the projects fail.
Thank you.
Cool.
Great. Thank you so much. Next, we have Alexander. Go ahead.
Hi,
Hey.
hi, Carlos. I'm really impressed by this topic today. I liked it very much. My question is kind of long, but let me explain. When you talked about garbage information being introduced, so then I started to think, what is the best thing to do when there are many inconsistencies in the historical data? And to give you some context, I was part of a cybersecurity project doing event categorization, and it was 100% human process and involved many different variables, and it was very subjective, and some of the criteria changed over time. So one person doing categorization a couple of years ago may be different from a person doing it today. So and knowledge was passed from one person to another. So I felt that the output of the system was very inaccurate, and we were trying to fit and make this more accurate from time to time, every iteration. So it would take, I felt like it would take years of clearing out that garbage data in order to achieve more accurate results.
Yeah, very. This is a great question. So basically, I think your purpose should never be to have clean data. That is not your purpose. Clean data is just a means to an end, and the end is a business outcome. And so, like the end, goes back to this process. Like, it's very important to understand what is the underlying goal of the application. This is business understanding. And it's also very important to have measures of success. And so it is possible to have kind of garbagey data, but not complete garbage. Like, it's inconsistent, it's dirty, but it's still good enough for you to achieve these key measures of success. And so there is this very famous quote in data science that says, all models are wrong, some are useful. So we never part from the point of building the correct model. We just say building the correct model is impossible because all models are wrong. And so our purpose is not to build the correct model. Our purpose is not to have clean data. Our purpose is to have a useful pattern, a useful model that I can use to improve business outcomes. And so the first thing that I would do is clearly define what the goal is and clearly define how could I measure whether the system is performing to a business relevant point, right? Now, that being said, let's suppose that we are below, right? Like, the system is very inaccurate. It's very inconsistent. I'm not there. So I'm not meeting the goal. What should I do? Essentially, I was going to deploy, but I couldn't because the performance sucks. So I need to go back to business understanding, which is, what do I do now, right? And so in those cases, I think there often is this idea that you can do either cleaning or you can do data collection, right? And so sometimes it is much better to work with a smaller but clean set of data than using all the humongous amount of data is just garbage and dirty. And so what I would start by doing is, okay, I have these humongous data set. What would happen if I just focus on 10%, the 10% of the data that I think could be most relevant, where most of the value is, and just trying to make that very clean? And so in some of my applications, for example, with retail companies, I almost always start with loyalty programs, because loyalty programs, you have much more information about those customers. People want to build a solution that, like, you say, oh, I want the data of all my customers. Yeah, but the data of all your customers sucks. It's super dirty. It's not accurate. But if I focus specifically on data from the loyalty program, I'm much more confident about what the data represents and that actually reflects the usage of these customers. And so because of that, I almost always, like, if I see the data is messy, I would try to look what people call these convenience samples, which are essentially like convenient for you because you know that it's not as garbagey, right? But again, all of these is going to be guided by your understanding of what the application is and by clear ways in which you're going to measure success so that you know when it is good to go or no, we need to keep working on this before this is in shape to be deployed.
Yeah, it totally makes sense. Thank you.
Great, thank you so much. Now, I think that we have time for two more questions. Collis, go ahead.
All right. Carlos, great to see you. And congratulations
Yeah.
on your success. I'm very happy for you. we have, well, since you left Gap, we've grown quite a bit, and we have a lot of people working on the admin area. So what is the minimum set of knowledge or things that we should know and learn to be up to date by now and not fall behind what's going on in the industry?
Yeah. So I think focusing on understanding the fundamentals is like a no brainer, right? So I think like it's easy to go and try to focus on the latest trends. So for example, I see people talking about, let's talk about GPT for a second, and then we're gonna go back to more traditional AI. So people say like, oh, I need to keep track GPT-4 and GPT Gemini, and all, like they're just like trying to catch up with the latest model. But I think going back to the fundamentals is way more important. So for example, what is the sort of business application that I could inform with GPT? How would I measure if this is good or not? Because I see people talking about, oh, you could use GPT for this and you could use GPT for that, right? Yeah, you could use it. Would it actually work? I don't know. Like, how do you measure if it's working? I would, like, if it's a critical application, no, man. Like, how do I know if the thing hallucinated or made things up? You know, like, I wouldn't trust it, right? And so having a clear understanding of the business application, having a clear understanding of how you measure that thing, I would put that as way more important than understanding what are the capabilities of GPT-4 versus GPT 3.5. It just doesn't matter. Like, it just doesn't matter at all if you don't understand what the business application is and how you're going to evaluate it, right? And so I think in that sense, if you understand the fundamentals better, it gives you a solid framework so that when new things come in, you can say, yeah, this is going to drastically change the fundamental or not. So in my case, for example, when GPT came in, it drastically changed my way of thinking of AI, because these things that I was showing you, this is called narrow AI, and it's called narrow AI because this predictive model, all these predictive models that I've been talking about, they're built for a very specific purpose, which is this a good hire or not? That's the only thing that it can do, right? Is a good hire or not? But it's not looking at responses for medical questions and law questions and all these things that GPT can. This is a general model, right? And so what is unique about GPT is a general model, right? And so that changed my understanding of the fundamentals. Now, if I were in an admin position, I would not go straight to Gen AI like GPT. I would go to the fundamentals of this narrow AI, understand these other cases that have been tested in battle. People know what they're talking about. And for that, I highly recommend maybe taking a look at data science for business. I think the fundamentals is really about understanding each of the components in this flow. If you can understand what each of these components, that gives you a good framework, because it's essentially what sort of decisions or actions could I inform with machine learning and AI? How should I use the predictions of a machine learning or AI to take these actions? What are the sort of things that I could predict, the data that I could have for predicting and making better actions? What sort of attributes or features do I think could be useful in predicting that thing? Do I have historical data that would actually align to the way in which the model will be used? And at the very, very, very last, what machine learning or statistical techniques can you use? Of course, that's important. I'm not saying it's not. But I would start from the action, and then how the predictions are used to take the action, what sort of predictions I could make, what could I use to make those predictions, what historical data I have. And then at the very, very, very end, then yes, you focus on the machine learning stuff. Again, take this with a grain of salt, because you're talking with a guy that is in the business school. But I'm a computer scientist. I did my PhD in data science. I have the technical background, but I'm in the business school and I work with applications. I'm not an engineer anymore. And so because of that, my perspective is different. So take this with a grain of salt of the person with whom you're talking to.
All right, thank you.
Great.
By the way, great to see you again. Sorry.
Cool, likewise.
Great. Well, I think that was our final question. thank you, Carlos, for all the knowledge that you shared with us today. We really appreciate your visit to GAP, and hopefully you can join us on future events. Also, to all the GAPsters who attend this session, thank you for your active participation. Okay. Tomorrow, we invite you to our final talk, Prompt Creation and Precise Communication with AI Models. In this talk, John Munoz will show us how to build the prompts to get better results in AI tools. Okay. I also appreciate if you can fill out the form of the feedback. That will help us in this case to improve our future events. One more time, Carlos, thank you so much for sharing the knowledge with us today. Okay.
Thank you very much for everything, guys. It was great seeing you all and seeing new faces and old faces too. Take care.